This is just a continuation of 9-6. But here is the absolutely mind-blowing thing. And I mean, I've always loved math, but I was a biologist. The moment, and I have seen this happen to students, and it is the coolest thing ever. The moment when you realize that the equation is actually describing something in the world, and that the numbers and symbols you are seeing describe an actual relationship between objects moving through space. This is the kind of thing that I really want you to wake up at 2 in the morning staring at the ceiling and freaking out about. We can do that. It is so cool. Now, here's the other piece of that. We got some standard representations for quantities that we use frequently. V, lowercase v. Oh, that's so important because we have uppercase v. That comes later. We won't get to uppercase v for quite a while. Lowercase v is speed. Looks like velocity, but it's speed until you add a direction. We'll talk about that in a couple chapters. That little triangle is the Greek letter delta. I was unfortunate enough one year in college to live right up the hill from a bunch of sorority and frat houses on the north side of Youngstown. And some of them used to drive around in trucks just chanting their Greek letters. It was like, are you going to forget it? But I did hear a lot of delta. But we will make some plays on that. We deal with changes in quantities a lot. So we talk about changes in speed as delta v. We talk about changes in position as delta x or delta y, because we're talking about a change in a quantity. Sigma is something that we use in chapter 4, and I will draw really messy sigmas, but that's okay. And sigma means sum. Have you used that in math? Do you use that in math? Okay. Advanced math or stats? Probability. Okay. Good. So you're familiar with it. T is time. There's a whole list in your book. You can go look at them. I'm going to read this sentence to you because that's a sentence. And I love the fact that with Common Core Math, my first grader came home last year talking about math sentences. And I'm like, that's right, honey. That's what it is. You're saying something. So delta y equals 3.2 delta t cubed. Be fluent in the math language. So the last thing that we are going to just briefly touch on is the thing that I sort of teased at in the beginning, which is this. You've been doing dimensional analysis for a very long time. The form of conversion that we do, that we call factor label, is really a form of dimensional analysis. The dimensions are things like meters and grams, length and mass. Length and mass are the dimensions, the units that go with it. So we're evaluating, we can use that fact to evaluate expressions to see if we've rearranged things correctly. Because like I said, you all know that if I take 10 grams divided by, or let's see, 10 to the third, a kilogram, that I have units that cancel, and I have units that multiply. And when I teach this in chemistry, back when I used to lecture, I would say, this is the gospel of factor labeling. If you line up your units correctly, the problem does itself. You're checking your units before you do the problem to make sure that all your numbers are in the right place. This is the exact same thing we're going to do in physics, except we're going to handle it a little bit differently. But you understand the concept that you can multiply and divide SI units. Now, could you add kilograms and meters? Is that legitimate? Talk at your tables. Discuss it with one another. Take a vote. Take a survey. Yeah, you all knew this. You're looking at me like I have a third head, but, could you? I don't know. She's asking. She's telling. No! Don't be ridiculous. You can't do that. You can multiply them, you can divide them, you can't add them, you can't subtract them. It's apples and oranges. So that said, let's do a little bit of actual dimensional analysis of the kind that we're going to use. Let's say we've got an expression for speed. So how long does it take you to get, well, let's see. This is going to be something we'll use a lot in the next chapter. Average speed, average velocity, is equal to the distance you travel divided by the time it takes you to get there. V equals delta x over delta t, miles per hour. So what if I'm given time and velocity and I want to know how far I went? I would have to rearrange this, right? Okay. What if I'm bad at rearranging three-part algebra? It's pretty common, actually. You'd be surprised. Okay, so that's easy. Delta t equals, delta t equals delta x times average velocity. I rearranged it, look. But like I said, I'm not good at rearranging three-part equations. So how do I check my work? I just plug in the numbers and hope for the best? It doesn't seem like a great strategy. Dimensional analysis! That's what we want. So to do dimensional analysis to evaluate your algebraic rearrangement, step 1, replace all of those variables with the units that they would be in. So time, we're going to measure in seconds. Distance, we're going to measure in meters. And velocity, or speed, would be in meters per second. So I'm actually going to, here's what I'm going to do. We're going to do this two ways. So let's say two friends both rearranged this equation. One of them claims that delta t equals delta x over the average, while one of them claims that delta t equals delta x VA. How do you evaluate who's right? So again, on this side, let's sub in all of our units. So S equals, then that would be meters over meters per second. Where do I go from here? So if, and this is something I've found that people struggle with. They're like, what do I do? Pretend there's a 1 in front of everything. Stick a fake number 1 in front of every single thing. Okay? Now, can you figure out what to do with those units? If you I had to choose like the most complicated, stupid example. Of course I did. Okay, well, anyway, such is life. Let's do the dimensional analysis on the original problem. How's that? I'll make it up to you. We'll go with blue for that. So on the original problem, we know that meters per second is the velocity, and the distance we're measuring in meters, and the time we're measuring in seconds. Hey! It matches. If it matches, you're good. If your units match, if you can multiply and divide as far as possible, and your units end up being the same, it's good. We're going to pick this up on Monday. Have a wonderful weekend.